Hello friends, in this video we'll be discussing trigonometric Fourier series, full range series, interval 0, 2 pi, problem number 2. Welcome back friends. Let's have a look on the given problem. Here we need to find it out Fourier series expansion of f of x, which is equal to pi minus x by 2 the whole square in the interval 0, 2 pi, and hence deduce. Deduction part, that is the second part, leave it for some time. Let's focus on f of x. Let's first of all find it out its Fourier series. This problem is one of the most important problem of Fourier series, asked number of times in the exams. First of all, let me tell you few basics for this that will be required for this problem. Pi minus x the whole square. What is the derivative of this term? Chain rule, fx raised to n fx raised to n minus 1. 2 minus 1 is 1 into derivative of fx. Pi derivative is 0, minus x derivative is a minus 1. This is the derivative of this particular term. If I'll take further derivative, this 2 and this minus 1 is constant, minus 2 is constant, and pi minus x derivative is minus 1. Its further derivative is 0. Pi minus x the whole square, 2 pi minus x into minus 1, further minus 2 into minus 1, and that's derivative is 0. What else will be required in the problem? Sin nx integration minus cos nx upon n, cos nx integration, sin nx upon n. What else? Sin n counter, cos n by minus 1 raised to n, cos 2n by 1. That's it. If you know this much things and follow the 3 steps, use brackets properly, sin n counter, always simplify before substitution, I can guarantee you, you cannot go wrong with the problem. You will get your solution. Let's start with the problem. Fourier series is given by a0 by 2 plus summation of n is equal to 1 to infinity an cos nx plus summation of n is equal to 1 to infinity bn sin nx. 3 things. As usual, we need to find out 3 coefficients a0, an, and bn. The formula for a0 is 1 upon pi 0 to 2 pi f of x dx, which is equal to 1 upon pi 0 to 2 pi f of x. F of x is pi minus x by 2 the whole square into dx. This denominator 2, if you take square, that will become 4. It's a constant, you can take it out, which is equal to 1 upon 4 pi 0 to 2 pi. Inside you will be left with pi minus x the whole square into dx. Friends, do you know the formula to integrate this? Let me tell you that formula. Integration of ax plus b raised to n. Ax plus b raised to n plus 1 upon n plus 1, and with x we do have a. See here, therefore I am going to divide by a. The same formula will be applicable here, 1 upon 4 pi. Let's integrate. You can expand also pi minus x the whole square by using the formula a minus b the whole square, and you can integrate. That you can always do, but this is simpler. This is pi minus x the whole square, n plus 1, 2 plus 1 is 3, upon 3, and with x, see here, with x we do have minus sign, therefore here it is minus, because it is minus x, and the limits are from 0 to 2 pi. You can take this minus 3 outside, so outside it will be minus 1 upon 12 pi. Let us substitute the limits. If you put 2 pi, we do have pi minus x, that is pi minus 2 pi. Pi minus 2 pi is minus pi the whole cube. Minus pi the whole cube is minus pi cube, minus lower limit. In place of x, if you put 0, that will become pi minus 0. Pi minus 0 is pi, that is pi cube. which will be equal to minus 1 upon 12 pi into minus 2 pi cube. This will be added. Minus pi cube will become minus 2 pi cube. This will be cancelled, and the final A0 answer is, this will be 2 pi square by 6. We got the first answer A0. Let's move on and try to find it out AN. 1 upon pi, 0 to 2 pi, f of x. What is the formula? Cos nx dx. Fx is pi minus x by 2 the whole square. Again, that 2 I am taking out. That will become 4 because it is a square. And here it will be pi minus x the whole square into cos nx and dx. What next, friends? U into v rule. 99% time it will be u into v rule only. This is u because this is algebraic term. This is trigonometric term. Therefore, it is a v. Let's apply u into v rule, which is equal to first point. What is the first point? Remember the point. Use brackets properly. See, the problem will be very simple if you follow the steps. Use brackets properly. 1 upon 4 pi outside. Let's integrate. U as it is. That means pi minus x the whole square as it is. V integration. Cos nx integration is sin nx upon n. Minus derivative of this term. As discussed, pi minus x the whole square. It is a chain rule. That is fx raised to n. 2 pi minus x raised to 1 into derivative of pi minus x. Pi derivative is 0, minus x derivative is minus 1. This derivative is complete. Let me keep it in this bracket because it's our rule. Whatever are the term, we're going to put in a bracket. Let's integrate this. Sin nx upon n minus cos nx upon n square. 1n from integration and 1 is the previous n. Alternate plus minus. Derivative of this term. This 2 and this minus 1 is minus 2. And pi minus x derivative. Pi minus x derivative is, pi derivative is 0, minus x derivative is minus 1. Done with derivative, I am putting in a bracket. Integration of this particular term. Its integration is minus constant cos nx. Cos nx is sin nx upon n. But already we do have n square, that will become n cube. No need to go ahead because its further derivative will be 0 because this is the term. What next, friends? Sin n counter. Because in the interval 0 to 2 pi, sin gets cancelled. And third point is, always simplify before substitution. This term will be encountered, this term will be encountered, and you are left with 1 upon 4 pi inside. This minus, actually in this term there are 3 minus. This minus, this minus and this minus. Triple minus is minus 2 pi minus x. And we do have cos nx upon n square. It's triple minus, therefore it will be minus. And the limits are from 0 to 2 pi. Let's substitute the limits. This is 1 upon 4 pi. Upper limit minus lower limit. If I'll substitute 2 pi, in this term minus 2 is there outside. Pi minus 2 pi is minus pi. This will be cos of 2n pi, 1 upon n square, upper limit done, minus lower limit. Let's substitute the lower limit, that is 0. If I'll put this minus 2 will remain as it is. If I put x as 0, this will be pi. If I'll put here cos 0 will be 1 upon n square. which is equal to 1 upon 4 pi. This is 2 pi upon n square. This is also 2 pi upon n square. Because both are minus, will be plus. We need to add. This is 1 upon 4 pi. N square is the LCM. In the numerator, this is 2 pi plus 2 pi is 4 pi. This will be cancelled, and we got the value of an as 1 upon n square. Is this clear? Let's move on. What next step? We need to find it out. Bn. Let's write down Bn. 1 upon pi 0 to 2 pi f of x. In Bn we do have sin nx dx, which is equal to 1 upon pi 0 to 2 pi. F of x means pi minus x by 2 the whole square, but divided by 2. 2 square is 4. You can take it out. And here it will be sin nx and dx. What next? Same old repeated story. This is my u and this is my v. What is the first step? Remember the steps. Use brackets properly. This is the first step, which is equal to 1 upon 4 pi u into v rule. U as it is. That means pi minus x by pi minus x the whole square as it is. Sin nx integration. Brackets properly. Minus cos nx upon n. Minus its derivative. Pi minus x the whole square. Fx the whole square. Twice pi minus x into derivative of pi minus x is minus 1. This derivative is done. I am keeping in a bracket. Integration of this term. Minus constant. Cos in nx integration is sin nx upon n. Previous n will become n square. Plus derivative of this term. Minus 2 constant. Pi minus x derivative is minus 1. We are done with this derivative. Let's keep it in a bracket. Integration of this term. Sin nx integration is minus cos nx, and we do have minus also with sin term. That will be plus cos nx upon n cube. No need to go ahead because derivative of this term will be 0. What next, friends? Sin n counter. Third point. Always simplify before substitution. Sin encounter, only one term will be encountered here. You are left with the two terms, which is equal to 1 upon 4 pi, and before substitution, let us simplify the brackets. This first term, I am just going to take this minus outside, that is minus pi minus x the whole square cos nx upon n. This is the first. And for this term, it is minus 2 into minus 1 for the third term. That is 2 cos nx upon n cube. Let us substitute the limits from 0 to 2 pi. For limits, always use curly brackets. If I'll substitute 2 pi here, it is minus pi minus 2 pi is minus pi the whole square. If I'll substitute in cos nx, that is cos 2n pi, which is 1, plus twice into 1 upon n cube, minus lower limit 0. If I'll substitute 0 in the first term, minus we do have pi minus 0 is pi, that is pi square, cos 0 is 1 upon n, plus twice, if I'll put here, again cos 0 is 1 upon n cube. If you see these terms, this and this will be cancelled, because if you open this, minus pi the whole square is pi square. This is negative positive will be cancelled. This is negative positive will be cancelled, because outside we do have minus. Everything will be cancelled. The answer of Bn is 0. Therefore, f of x, what is the solution? a0 by 2 plus summation of n is equal to 1 to infinity an cos nx plus n is equal to 1 to infinity bn sin nx. a0 by 2. Let's check the value of a0 that we got. This is the value that we got. a0 pi square by 6. Therefore, it is pi square by 6, but in the denominator we do have 2. Therefore, that will become pi square by 12 plus n is equal to 1 to infinity. an value we got it as 1 upon n square and bn value is 0. Therefore, the required solution f of x is pi square by 12 plus summation of n is equal to 1 to infinity 1 upon n square cos nx. This is the required solution. What next? We got 6 marks. But if you observe the problems, there are 3 more deduction given based on this problem. Let's check that. 3 deduction, pi square by 6, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square, pi square by 12. This is actually pi square by 12. 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square, and it is alternate plus minus. And for the third part, it is pi square by 8. Now we need to find it out, this deduction based on this solution. First of all, friends, if you observe the first deduction, see here, we do have 1 upon 1 square, 1 upon 2 square, 1 upon 3 square. First of all, let's simplify this. F of x means pi minus x by 2 the whole square. This is pi square by 12 plus. This summation means we need to put the values of n. Initially, n is equal to 1. Therefore, it will be 1 upon 1 square into cos x because n is 1. Let us substitute in place of n 2. 1 upon 2 square cos 2x. If I'll substitute in place of n 3, 1 upon 3 square cos 3x plus dot dot dot. This is my required solution. From this, I need to prove these deductions. If you observe the first deduction, here it is 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square. That means we want these terms, 1 upon 1 square, 1 upon 2 square, 1 upon 3 square. We don't want cos term. That means we want cos term to be 1. For that purpose, see here, put x equal to 0. Let's substitute it. Let's do it. Put x equal to 0. In the left hand side, if I substitute x equal to 0, it will be pi by 2 the whole square, which is equal to, right hand side we do have pi square by 12 plus, this is 1 upon 1 square. If I'll put x equal to 0 here, this will be cos 0. Cos 0 will be 1. This will be cos 2 into 0. Again cos 0, 1. This will be again cos 0. That will be 1. You will be left with 1 upon 1 square, 2 square, 3 square plus dot dot dot. Therefore, if you take this side, this will be pi square by 4 minus pi square by 12 is equal to 1 upon 1 square, 1 upon 2 square, 1 upon 3 square plus dot dot dot. If you subtract this, you will get pi square by 6, which is 1 upon 1 square, 1 upon 2 square, 1 upon 3 square plus dot dot dot. We got the first deduction where we substituted x equal to 0. Now let's check what is the next deduction. If you observe this deduction, we do have alternate plus minus sign. 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus dot dot dot. It's alternate plus minus sign. Therefore, what needs to be substituted? Cos 0, 1. Cos pi, minus 1. Cos 2 pi, 1. Cos 3 pi, minus 1. If I'll substitute x equal to pi, my work will be done. Let's see how. If I'll put x equal to pi, this will be cos pi. Cos pi will be minus 1. This will be cos 2 pi, 1. This will be cos 3 pi. minus 1, and I'll get alternate plus and minus. Therefore, I need to substitute x and pi. If I'll substitute x as pi, left hand side will be 0 because pi minus pi is 0. And here I'm going to get the alternate plus minus. Let's do that. Put x equal to pi. Left hand side it is 0 because pi minus x is there. Pi minus pi is 0. Pi square by 12. We do have 1 upon 1 square into cos x. Cos pi is minus 1. Minus 1 upon 1 square. Plus 1 upon 2 square, and we do have cos 2x, that is cos 2 pi, which is 1. Then we do have cos 3 pi, which is minus 1. See here, we are getting the alternate plus minus sign. And here it is plus. Let's take pi square by 12 this side. Therefore, it will be minus pi square by 12 is equal to minus 1 upon 1 square plus 1 upon 2 square minus 1 upon 3 square plus dot dot dot. If you take minus common from both the sides, we're going to get 1 upon 1 square minus 1 upon 2 square minus taking common, and that will be cancelled from both the sides, which is pi square by 12. This is the next deduction that I got. Minus took common and got cancelled from both the sides. What is the last deduction? For the last deduction, friends, here it is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. If you observe, in the last deduction, only odd terms are there. In the last deduction, only odd terms, 1, 3 and 5. How can you get that? See, just add 1 plus 2. 1 and 2 deduction that you got, just add. If you add, see here, this will be cancelled because 1 is plus, other is minus. If you have the next term, let's say 1 upon 4 square, that will be cancelled and so on, and you will be left with only odd terms. See here. Therefore, for getting odd terms, we just need to add the deduction 1 and 2 that we got. Let's do that. Add 1 and 2. This is the first deduction, that is pi square by 6, and the second deduction is pi square by 12. We need to add. Therefore, pi square by 6 plus pi square by 12. On the right hand side, as discussed, either the terms will be cancelled or it will be twice. Why twice? Because 1 upon 1 square from the first term and 1 upon 1 square from the second term, that will be added and that will become twice. 1 upon 2 square, in the first it is positive, in the second it is negative, that will be cancelled. 1 upon 3 square, again in the first and third equation will be added. So either the terms will be added or they will be cancelled. Plus dot dot dot. If you add this will be pi square by 4 to 1 upon 1 square, 1 upon 3 square plus dot dot dot. This 2 will come down and you will get a pi square by 8. That will be our required deduction. We got all the 3 deductions. Friends, deduction part is very simple. Generally, you just need to put x equal to 0. Try with 0, pi, 2 pi and so on. Hope you understood. This problem is very important. We are done with the problem. In the next videos, we'll discuss few more examples. Thank you.